Hi everyone, this is going to be a lecture about the preferences over time. So the idea is that everything that we have done up until this point, there has not been any element of time. And so what I mean by that is there is no sense in which you buy some apples and bananas and then later on you eat them and you experience utility. Everything sort of happened all within an instant. And so what we want to do now is to sort of add that complexity in, right? So we want to take into account that sometimes you're making decisions in the present that are going to impact your consumption in the future. And so in order to sort of get a start on that, let's just start off with the following maybe obvious observation, which is, if you had say you had $200 to consume over the course of two different time periods, it would make a lot more sense to consume $100 in the first time period and $100 in the second time period, rather than, for example, like spending all $200 in the first time period and then having nothing left in the second time period. So the idea here is that people have a preference for smoothness. And so what I mean by smoothness is just that, if you have, some lump of money, you would prefer to split up the consumption so that you consume the same amount in each period. You don't want to have one period where you're eating really fancy steaks, and then in the other period you're eating like the cheapest ramen. And so that's the idea. And so what we're going to spend today doing is to sort of how to think about that in a more precise way, and then also to think about what are some of the implications for people's preference for smoothness. So what I want to do to start off with is just to introduce a utility function. So in this example, our two goods are just going to be consumption in period one, so consumption in period one, and good two will just be consumption in period two. So these are both going to be measured in dollars. And so the idea is, when we say you consume $100 worth of stuff in period one, the idea is you take that $100 and you spend it on whatever would give you the highest utility. So, one way that you could set up a problem like this is to talk about apples in period one, bananas in period one, apples in period two, bananas in period two. But that's just complicated, right? If you have four different goods, then you have a lot of different moving parts. And so this is a way that we can simplify and talk about what we really care about right now, which is preferences over time. Okay, and so here's what I want to do. So what I want to do is say, suppose that someone has preferences. The utility from C1 and C2, of course that's consumption in the first period, consumption in the second period, is equal to the square root of C1 plus the square root of C2. Okay, so these are a particular combination of preferences. So let's just take a couple of quick examples to see how this person feels about some various bundles. Okay, so U of, say, 100, 100, just is equal to would just be equal to 20. And so let's look at a couple other bundles that would have the same utility, just to get a sort of idea about how this person makes trade-offs. Okay, so let's see, for example, the utility of 81 and 121 is equal to root 81 plus root 121, which is 9 plus 11 is 20. So notice what's going on here. So the sort of total amount consumed. So if you just sort of add up how much the person consumed in the first example, you would get 200. But then if you looked at C1 plus C2 in this example, you would find that this is 202. So it's not a big difference, but what we can say is that since this person has a preference for smoothness, and so by the way, we'll sort of circle back in a second and talk about why exactly this utility function indicates a preference for smoothness, this square root of C1 plus the square root of C2. But the idea here is that this person is equally happy between 100 and 100 as they are between 81 and 121, even though there's a little bit more sort of total consumption in the second example, just because this person likes to have a more smooth consumption. So let's do a really extreme example. So 0 and 400 would be equal to root 0 plus root 400 would be equal to 20. And so what that's saying is that 0, 400 is indifferent to 100, 100. So the idea is we're talking about a person who, they would generally prefer the consumption pattern that was, not too high, not too low in every period. But if you give them enough consumption in one period, then that would be as good as consuming 100 in each period. So the idea is that, this person is not just single-mindedly devoted to making sure that they don't have too little in their lower period. Okay, so let me just note one other thing just for completeness here. So we also know that 81, 121 is also indifferent to 100, 100. So let's ask why. So why is it that this root C1 plus root C2, why does that indicate that we have preferences, where, for example, so these preferences would also tell you, by the way, that 100 is much preferred to, say, 0, 200, right? So we know that we would much prefer to have 100 in each period rather than 0 and then 200. And so let's just see why for a moment. So we'll just plot C1, although it's the same for C2. So if you have C1 on the horizontal axis and the square root of C1 on the vertical axis, then the square root function looks kind of like that, where it's very, very steep in the beginning, and then it gets flatter and flatter and flatter. And so the idea here is that the marginal utility of C1 is very high when C1 is low. So let's just see why that is for a second. So the marginal utility of C1, and like I said, this is the same story for C2 as well. We'll just use C1 as the example. So the marginal utility here is d utility of C1, C2, dC1. Now we just need to go back to our function of u of C1 and C2. And so we would find out that this is 1/2 times C1 to the negative 1/2. So this was, you could find this just by rewriting C1 here as C1 to the 1/2 and then using the exponent rule. So this is what you would find. And so this is just, so this would be 1/2 times 1 over root C. And so when C is very low, this marginal utility is going to be very high, right? So imagine when C is like 0.01, well, this square root of C is also going to be something that's very small. And then 1 divided by that very small number is going to be something gigantic. And so the idea is when your consumption in a particular period is very low, then adding a little bit more will be very valuable, right? So that is why, if you had, if you had this, say $200 to spread around between consumption in period 1 and consumption in period 2, you would always want to do an even split because that's how you would maximize your total utility. All right, I'm going to keep these videos in small chunks, and so I'm going to pause the camera right here and we'll come back in just a moment.